Okay, any questions on the first three? Are we good at finding outliers mathematically now? Okay, now let's take a look at the next one. So we have the range on number 4. We have the mean, median, and mode. Now, which measure of central tendency best describes or best represents the data? You can go with either. They're really, really close. Just have a good justification for why you picked the one you picked. Now, if we switched out the 42 with the 88, what would be most effective? Well, the median wouldn't move at all, would it? So it would not be affected at all, but the mean would change the most. Any questions? All right, let's take a look at the bottom. So the range for these was pretty easy to find. The mean absolute deviation, several of you just made up stuff and wrote the numbers there. So I need you to make sure you know what you're doing.
Wait, what's
Seattle is 0.93 repeating.
I got it wrong.
And Boston is 1.47 repeating. In just a moment, we're going to do this on the calculator together. And I'll show you how to use the black calculators. You cannot use any other calculator. You must use the black ones because that's what my directions are for. Every class period I have said that. And halfway through every class period, I can't find that button on my calculator because it's not the black one.
Is there any other calculator?
No, just that. Okay. Now, number 6, symmetric. Now, I drew the curve instead of the histogram, but it would be a histogram that looked very similar on both sides. Do you see this one on the board here? Is it mirror image? No. But is it pretty close to symmetric on either side? Yeah. So we would call that one symmetric. Okay, the next one, uniform. Uniform is quite similar on the top. Let's look at the board. Do you see, is it a straight line across the top? No, but if we just ignore that one little bar, is the rest of it pretty much the same? Yeah, so we could describe that as uniform. Okay, this is skewed right because the tail of the data is to the right. This is skewed left because the tail of the data is to the left. All right.
Well, for you that would be right, but for me it was left.
Correct. All right, any questions on describing the shape of the distribution?
Oh,
all right.
So when it's skewed right, then the right end is shorter.
Yeah.
Oh, no. I had it backwards.
Yeah. It actually makes sense backwards. And when you get higher up, what you're really comparing is where the mean of the data is versus the median of the data. And that really helps with the definition of skewness. But we're not going that deep into it. But if you were to take AP Stat your senior year or take AP Stat at some point to try to get another elective, you'd go more in detail into this. Okay? All right. Now, let's go through how to find the mean absolute deviation using the calculator. Now, this first time we do it together, it's going to seem painfully slow because I have to make sure everyone's following the directions. And it's hard to get 26 people to be attentive for a full 5 minutes. It is. I know.
That's the problem with this country. I'm sorry.
Okay.
You're the problem.
Thank you.
That wasn't a compliment.
Oh, but it was.
Mary.
Oh, I get you like great, but I would have gotten some. You use your own fun.
Okay. I typed up these directions in between the classes. So let's see. I talked to everybody through the first 2 class periods. That did not go well. So first thing I want you to do is hit the data button. I want you to clear L1 and L2.
Wait.
I'm not waiting yet. Okay, so hit the data button, clear L1 and L2. Okay, if you do not remember how to clear L1 and L2, it says to clear L1 and L2 by pressing data again, and then press 1 to clear L1, and then go back, press data again, and press 2 to clear L2. Or you can do 4 to clear them all at once.
Oh, wow.
That would have been better. I'll change my direction.
That is so cool.
That's a better direction. Press 4.
It takes so long to go with delete. so nifty.
To you all.
Okay, now what I want you to do is input the data into L1. So press data again and input your data into L1.
Which, just data from,
The data for Seattle.
okay.
The data for Seattle.
No, the white.
Okay. So as you're doing data, I'm going to talk about the process here. What we're doing is making the calculator, manipulating the calculator to make it do all the processes to find the mean and absolute deviation. So let's talk about mean and absolute deviation real quickly. The procedure for that is first to find the mean of the data. Then we subtract the mean from each piece of data, take the absolute value of that, do the sum of the absolute values, and divide by how many there are. Those are the steps for mean and absolute deviation. So we have entered the data. How can we use the calculator to now find the mean of that data? Second, data. Then press 2 for one variable stats and record the mean.
N is the mean, right?
X bar.
Oh.
N represents the number of pieces of data.
Oh. Can I have a
Okay, did you get an X bar or a mean of 5.75?
Yes.
Okay, if you did, that means you entered your data correctly. Now on your test, when you enter the data, if you're doing okay on time, I would arrow back up and double check to make sure I entered all the data correctly. Wouldn't that be a good thing to know? Okay. All right, so now we have the mean. Record the mean on a piece of paper. 5.7. Okay, now we're going to press the data button again. Did that put it to where you can see the columns? Okay, now what we're going to do is work in L2. So arrow over to where you're in L2.
Do we enter the Boston?
Nope. We're just dealing with Seattle right now. If you want to do Boston, you can do it later. Okay, is everybody in L2? Now, we're going to tell the calculator what we want it to do. We want it to take everything in L1 and subtract the mean from it. And we want it to take the absolute value of that, don't we?
Yeah.
Those are the steps for mean absolute deviation. So, we want to enter a formula. Press the data button again. That's usually where we clear. But what is the other option here? A formula. Arrow over to formula.
Oh.
And we're going to add a formula, so press 1. Okay, so what we want it to do is the absolute value of the difference between each piece of data and the mean. So we have to find the absolute value button on this calculator. The way we get there, press the math button. It's catty-corner to the little blue button up at top. Do you see the math button? Okay. Arrow over to number.
Would we press it now?
Yes. Okay. Does everybody see that choice 1 is ABS? On this calculator, ABS represents absolute value. So press 1 for absolute value.
Oh my gosh.
Does it open up a set of parentheses?
Yes.
Okay. Now we want it to do L1 minus the mean. We entered all our data in L1. Hit the data button one more time. What do you see? L1. So press 1 for L1.
Most parentheses?
Not yet,
No, not yet.
because we want to subtract that average from L1. So Now, once you have the L1 there, then do minus,
5.7.
what was the mean?
5.7.
Minus 5.75, and you can close your parentheses.
That's fantastic.
So how are we supposed to remember this?
And then enter.
And hit enter. And guess what it does for you? Every mathematical step.
That error.
That.
That's a lot of math.
That means somebody did that.
Wow.
We have like a step-by-step sheet for this.
Yeah, that we can.
How could I do something wrong?
That's
What did I do?
This is for MH.
Got a sack wrong.
That's what you wanted it to say. I don't know what it said a minute ago. Okay. Now that is just the list of the numbers. The last step in mean absolute deviation is to add up the absolute value of those differences and divide by how many there are. Isn't that just average?
Yes, ma'am.
So if we found the average of L2, that is the mean absolute deviation. How do we find average?
Second data.
Second data. Then press 2 for one variable stat. And the mean is your mean absolute deviation. Oh, yes, you have to change it to L2.
Second data. Change it for L2 for both of the, we have to go to L2 on, is the frequency? No, it's still one.
Yeah. Wait,
That
so
is L2.
it's 0.933.
Wow, I got it. Is yours
Oh, I'm like,
0.933?
Look at that.
Mine's
Two.
0.933. Is that a 2? I got that too, yeah, 0.9.
what did you do?
Go ahead and
You just helped me solve it.
I got it, it's supposed to be.
Actually, I'm
I use this map for
It's like
real life.
dirty straight.
Alright. Did you get 0.93 repeating?
No. I got.
Did you get the
Garrett,
5.75?
too far.
Please, no.
Did you get 5.75 exactly?
Let it go.
I bet there's one.
Like, oh, I thought someone else, and then I just walk out.
You know you'd be killed.
No, the Ben just Louis walks. Didn't you like jump at Louis? And use your powers.
I was starting like there.
He's just like levitates you with his mind.
I got it.
Just stares at you and slams the wall.
I love you.
I'm gonna throw that away. Trash can's right there, bro. It's like really close to me.
Okay, so that's how we can use our calculators. I will post these directions on my website if you want.
Yes.
Okay? All right, I will do that. Okay, today what we're going to do is going to learn about a little more about the histogram. Okay, what we're going to concentrate on in this class is something that's called a relative frequency histogram. But before we do that, I'm just going to show you how to do a frequency histogram. But we're going to concentrate on the relative frequency, which means relative to the total population. All right, histogram. We're going to start with a frequency distribution, which for us, I'm going to set up a table, and you're going to fill in the information, and that will be our distribution. A frequency distribution is where we group the data into categories showing the number of observations of each mutually exclusive class. Now, what that means is there's no overlap. So if I let the first class be children ages 2 to 5, Then the next class could start with children ages 6 to 9. There's no overlap. You can't be 5 and 6 at the same time. Does that make sense? Okay, so that's what we're looking at. Now here's an example. What I'm going to do is talk you through the whole PowerPoint, and then as a class we're going to do an example together. I'll put the PowerPoint on my website. I borrowed this from somebody on Google that had it out there for people to use.
You don't have it on
Yeah.
your website, or you do?
I will.
Oh, you will.
Mm-hmm. Right now you're just watching them. Okay, so Mr. Bagdanus is the city manager for the town of Geneva, and he's been by the city council to study the water usage in the community. He selects a sample of 30 families. Now 30 is a good number. When we're looking at samples, which as you get further into statistics, the further you go up in high school, you do want a sample of at least 30 to be a good representative sample. So a sample of 30 families, and determines that the number of gallons of water used by each family last year. The data is reported in thousands of gallons. So when the first one says 15, that doesn't mean they flushed the toilet 5 times and used 15 gallons. It's 15,000.
That's a lot.
Okay, so here's our data. That's 30 pieces of data. Okay, so how do we organize this data? Well, we have to come up with our intervals on how we're going to divide up the data. And we'll talk about specifically how to do that in a minute. We don't want overlap. So when we're looking at this example, and we wouldn't write it exactly like this, but this is from 8 up to 13, but not including 13. This is from 13 up to 18, but not including 18. And then what we do is we go through here and we count. How many fall into this range? Well, 1. So our frequency is 1. Frequency just means the count. So we're counting how many there are. Okay, now how many are from 13 to 18? Okay, so we're marking out all those. There are 12 that fall in that range. From 18 to 23, that's the red ones, there are 10. From 23 to 28, there are 5. From 28 to 33, there's 1. And from 33 to 38, there's 1. Now what should the total be?
30.
30, because we had a sample of 30. So good, our frequency should add up to the total. Now, we're going to talk about how we get the class intervals and where we could put the midpoints in just a minute. So this is what that frequency distribution looks like.
Ugly.
It looks like a histogram, doesn't it?
It's skewed right.
Skewed left.
Ooh.
Skewed right.
Is it always in the
Skewed right.
beginning that's a lot shorter?
No, they can all look different. Okay, so do you see how they titled it? They labeled the axis and what it represents. Okay, that's what you'll need to do also. Okay, so lower class limits or lower bounds, it could also be called, are the low numbers of our classes. Upper class limits are the higher end of our classes. Now, the midpoints. To find the midpoint, you're going to do the averages. Midpoints are important, but not so much for what we're going to be doing this year. It's more important for what you're going to be doing in a higher level math class, because I could just give you the graph and you would have to work backwards and find the data. And to do that, you would need to be able to find the midpoints. We're going to label our class intervals with the lower and upper boundaries. They can also be labeled with the midpoints, and that's what you would use if you were given the graph and had to work backwards. We're starting with the data and we're making the graph this year. Okay, class width is the difference between two consecutive lower class limits. So what is 31 minus 21? 10. 41 minus 31? 10. 51 minus 41? 10. Do you see that they're all the same? Now, some of us want to go, okay, how many pieces of data could fall between 20 and 30? And we got 30 minus 21 is 9. That is not true. Let's count. Fingers. Okay, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. How many fingers is that? 10. 10. So, when we're looking at the interval, if we just subtract the lower from the upper, what we've done is we've ignored the lower value, which is part of it. We said take the first 30 pieces of data and take away the first 21. We don't really mean to take away the first 21 because 21 actually falls in this interval. So if you're going to subtract the 2, you have to add back 1 to account for that. So if we do it that way, what is 30 minus 21? 9. Add back 1 for the 21, so it is 10. The SAT has questions like that on it too. I mean, they seem really obvious. When we count them on our fingers, they look obvious. But when we just subtract stuff, it gets us sometimes. So pay attention to that. So the class width is 10. All right, how do we decide the number of classes? Well, you. No, literally, I will tell you this year. It's going to be 5. It doesn't have to be 5. It could be somewhere between 5 and 20. But for us, since we're just kind of doing an intro to this, we're just going to stick with 5. So, how do we find the class width once we've selected our number of classes? Well, for us, it's going to be 5 every time down here for the number of classes. But you do the range divided by the number of classes you want, which for us is going to be the range divided by 5. It doesn't have to be 5, but we're choosing 5 for the sake of simplicity. Okay? All right. So, here's an example that I made up. All right. So, I edited this person's PowerPoint that they put out there for us, apparently me to steal. All right. Histogram of mothers' ages of the seniors. A randomly selected. Okay. Adopted. They adopted an older child. It's okay.
Okay, that really confused me.
It's okay. They adopted an older child, so it's okay to have a 30-year-old mother.
I'm sorry I saw that.
I know. All right. Now, I was really nice and I put the data in order. Wasn't that nice? I'm not always nice.
But you're
So-
pretty.
Thank you, Mary. Woo!
Best student award.
Right there. Mary just earned it, didn't she? Okay, so let's talk through how will we do all this. The first thing, I will tell you, 5 classes.
5 classes.
1, 2, 3, 4, 5. They're already done. So how did we come up with those? So what you do is you take the range. What was the highest piece of data? 54. Subtract the lowest piece of data, 30, and divide by 5. So this gives me 24 divided by 5 is 4.8. We are always going to round up. So my class width is going to be 5. Each class width will be 5. So I start with my lowest, my least value, and that's my lower limit. Add 5. That's my next class. 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 So, then what is 1 less than 35? 34. 1 less than 40? 39. 1 less than 45? 44. 1 less than 50? 49. The next one would be
Less than 55.
54. And then what we do is we count. We do a tally. Now, honestly, I am not going to be grading this. I'm going to be grading this.
That.
Okay, because you learned how to do tally marks in 2nd grade. Actually, you did. It was either kindergarten or, and you learned how to do these kind of tally marks in kindergarten. And 2nd grade is where you learned to put the slash. Yeah, that was 2nd grade. All right, so you just count. You just count. Now, I told you we're going to practice midpoints, even though we're not really doing a whole lot with them. We're going to practice midpoints, so add them up, divide by 2. 30 plus 34 is 64, divide by 2 is 32. 35 plus 39 is 74, divide by 2 is 37. 40 and 84 divided by 2 is, okay, do you see how these are going up by 5?
Yeah.
Doesn't that make sense since your class width is 5? Okay.
Oh.
Yeah. All right. So once you find the first one, you can just add the class width to get to the rest of them. Got it? All right. Relative frequency means relative to all the mothers of seniors. What percentage falls between 30 and 34? So you take the frequency, divide by the total. That's your percentage. Frequency, divide by the total. That's your percentage. Frequency, divide by the total. That's your percentage. So we can say that 40% of the mothers are between 40 and 44. Does that make sense? And then we can graph this data. I'm going to show you both the frequency distribution and the relative frequency distribution. Okay, I got some real bright ones in here. So, how do they look different? They don't, do they? They're the same. But they mean different things. Okay, I would count off on this, even though I appreciate this person putting it on the web for me, because the axes are not labeled. Ages of mothers. This is not labeled. Ages of mothers. And they're not titled either. This is the frequency histogram. This is the relative frequency histogram. That's not a cue. Of the ages of senior mothers. Alright, there we go. Good enough. Now this is the one we're going to focus on. Let me talk about the difference in these two. Let me just talk about it. Okay, this one almost looks like a bar graph. They actually both do. But a bar graph that has the percentages is now a histogram. Because if you look at it from a mathematical perspective, this one is frequency. We're looking at the height of the bar. This one is the percentage. We're looking at the area of the bar. How much space is this versus how much space is that? So with a relative frequency, we're the percentages, and we're looking at the area of the bar. Once again, this is intro to stat, and I'm not going to be that picky. But what we're going to focus on is the relative. All right, we're going to do one together now. Pass these back quickly. Go ahead and read, and by the time I get them all out, you should be close to done. Okay, I'll read it to you then.
Tell us.
Word.
Best feature
You need one more?
Thank you.
I didn't count.
I'm just glad we're
This is really neat. It tells us it tells us the number of classes we should
Let's
have
not
and
yell
asks us
now.
how many classes we should have.
Sorry. Okay, so says the following sample data sets test the number of minutes 10 internet subscribers spent on the internet during their most recent session. Construct and graph a frequency distribution that has 5 classes. We're going to do a frequency distribution, and then we're going to do a relative frequency histogram. Okay? So, first, figure out the number of classes. What did I say we're going to do?
I don't know.
5. What did the page say we're going to do? 5.
4.
It says 5. It says, construct a graph of frequency.
Can I interrupt so bad?
Okay. All right, now we find the class width. What is the maximum value?
100.
100. What is the min value? 7 divided by how many classes? 5.
6.
This is 18.6.
Select.
But we round up to 19. Okay, so now we can go ahead and do our lower and upper limit. So our lower is going to start with a 7. That's my lowest. What am I adding to 7? 19, because that's our class width. So 19 gives us 26. 19 gives us 45, because 19 is 1 less than 20, right? So in your head, you're going 45 plus 20 is 65, minus 1 is 64.
It makes sense.
83.
Oh, I see what the way you're doing.
Okay, so the first thing we're going to do is our lower limits. Lower bounds.
You're horrible.
Okay, so 1 less than 26 is 25. 1 less than 45 is 44, and then 63, and then 82. Okay, do you see that I'm adding 18 in here? So that would be 101. Okay, you can watch it again later.
The part that's cool is that it goes right to 101. Does that happen all the time?
It'll go pretty close to your upper limit.
That's cool.
Yeah. All right, now let's count. What is the frequency of
1.
the minutes between 7 and 25?
1.
Okay. 45 to 63?
Wait, 26 to 44.
No.
No.
Oh, from 45 to 63, it's like 1, 2, 3, 2.
2.
Sorry, I can't count.
I said
Okay,
go.
64 to 82?
2, 3, 1, 2,
Hard.
3.
3. And then from 83 to 101?
3.
3. Okay, so what we did was we looked back up at the top of the page where our data was. How many pieces of data are between 7 and 25? 1. How many pieces of data fall between 26 and 44? 1.
Okay.
How many pieces of data fall between 45 and 63? 2.
I thought we were doing like minus all this stuff. I was like, what are we doing?
Okay, now the midpoints. Add them up, divide by 2. So what is 7 plus 25?
32.
Divide by 2? 26 and 44 is 70. Divide by 2?
39.
35. Didn't we say you'd just be adding the class width every time right here? Is 16 plus 19 35? Yeah, plus 19 is? Plus 19 is?
No, it's only plus 9.
19 is?
That sounds like Martinez.
Because 45 plus 19 is not 54.
Nope, but 35 plus 19 is.
Oh.
My middle name is April.
Okay. Now, once again, the midpoint is more important when we're given the graph and we're trying to go back and give information about the graph. You can also do a histogram where instead of giving the intervals at the bottom, you list the midpoints. You could. We're not going to, but you can. Okay, relative frequency. Relative
10%.
frequency is 1 out of 10, or 10%.
10%.
Relative frequency is 1 out of,
10%.
or 10%. Relative frequency is 2 out of 10, 20%. 3 out of 10,
I see what you did there.
30%. Didn't I give myself a nice easy one? Wouldn't it be nice if I gave y'all nice easy ones? Yep, it would be nice. It won't happen, but it would be nice.
But we're best friends.
Mary, not best friends.
She's done this to just about every teacher she's had, honestly.
No, I'm pretty sure we made like a contract or something that said we were.
Just ignore her. She's done it to a lot of teachers, and they've been creeped out by it. I'm surprised she's even allowed to step in this room.
All right, so for this particular one, I'm going to show you both the frequency distribution and the relative frequency distribution. Are they going to look similar? Oh, yeah. And then after this, what did I tell you I want from you?
You want me to
Not so. Basically.
I just want the relative frequency after this. Okay? So on your homework, you're just giving the relative. Thanks. All right. So what we're going to do is we're going to put our intervals on the bottom. So 7 to 25. 26 to 44. 45 to 63. 64 to 82. 83 to 101. Okay. For a frequency distribution histogram. It's really more of a bar graph, but we'll call it a histogram
To 82?
because we're going to connect the bars. They're going to be side by side. So we're doing a frequency distribution histogram of internet use times. That's what it is. So that's a good title. Alright, so do you see how I've titled it? Now I have to label my axis. So down here I put number of minutes. And then up the vertical axis is going to be the number of people, or the frequency.
That was not recorded.
It definitely wasn't me.
It was Drew.
Okay, so we've got 1 person, 2 people, 3 people, and that's really all I have to do, because my highest one had 3. So then I'm going to do the top of the bars where they need to be, the top of the bar, because that's what we look at on this one, not the area. We're looking at the top of the bar. Okay. There she is. Now, how different does this look from the other one? Not different at all. It's different in the way we interpret it.
You're skewed left.
So, now we're going to do the relative frequency distribution. Guys, I really don't want to have to do this, but if y'all keep making lots of weird sounds, then I'm going to have to give detention, because today you're distracting me. I don't like that. And the people beside you probably don't like it either. They've just been putting up with you. I see people in the hall. Is it time for you to go? Yeah. Okay.
What?
Go beat whoever y'all are swimming against. Is it more than one school?
There's like 4 of them.
Ooh, ooh. That beat a lot of people then. Yes. It's always good to have the really fast person on your team. Okay. So, same idea.
And swim hard.
Oh, wait, let me give you your homework though.
Oh, it's really impressive.
I know.
She just went a little
Swim
faster. She
with
would
purpose, Dory. Swim with
The purpose is not to drown.
Be quiet.
It's true though.
You made me angry. So
Okay.
I'm gonna hit you.
Okay, so we're going to finish this up.
Good way.
Alright, so it looks the same. It looks
Yes,
the
it
same,
does.
except we label our axis differently. The intervals even look the same. But this is still number of minutes. But this is now percent of the population, the relative frequency. Relative frequency, which is the percent of the population, whatever I'm looking at. Whether it's a sample population, okay, so what we have now is I think we're good. We have about 10 minutes. I'm going to go ahead and let you start your homework. Okay?
You rocket everything.
This is gonna be like number